Hey everybody, this is the second part of SD-WAN series, and in the part 2 our agenda is going to cover all the major players in the SD-WAN market and what are the benefits we are going to see and how the MPLS to hybrid connectivity model looks like. Then we are going to talk about SD-WAN load balancing mechanism and what are these load balancing techniques are provided by different SD-WAN vendors. And finally, we are going to talk about the third-party security integration. So let's get started. So if you look at my slide, these are the major players in SD-WAN market. So let's talk about Cisco Meraki, Cisco Viptela. The third player is going to be Silver Peak, Varsha Network, Valo Cloud. It comes from the VMware. Then you have Talari. It comes from the Oracle. You have a Juniper and many more. How SD-WAN solution helps us? So we already talked about reduced cost, improved security of the network infrastructure, faster and simplicity in terms of the deployment, in terms of the management of the infrastructure. Then we are going to talk about the cloud integration. As we know, most of the enterprise, they have moved their applications, which is going to be the cloud hosted. It can be IaaS, it can be something based on the past. So how is SD-WAN fabric can be extended to the cloud to get the better performance? So this is MPLS to hybrid WAN connectivity model. From one branch to data center, you still have one link which is based on the MPLS. Another link is going to be the cheaper and you are going to utilize this from the internet infrastructure. Then you have DIA traffic. Any traffic which you want to pass to cloud, maybe direct internet, you can bypass this and send it over directly to your internet infrastructure provider. And the reason behind doing it, let's say I have some traffic which goes from branch to data center, and from data center it reaches to cloud. So it adds the latency and you need some extra capacity of internet here on your data center. To reduce the latency and get the better performance, you can redirect that traffic over DIA. So load balancing, all these major players, they claim they can do the per packet load balancing or maybe the per flow load balancing. So let's try to understand how the per packet load balancing works. Let's look at the animation. You have one machine which is trying to send one flow over the branch to branch connectivity. So my first packet, it goes from MPLS. Then the third packet reaches to SD-WAN equipment on the remote branch. Then second packet, it reaches from internet infrastructure, and fourth packet as well. Here what I have seen, when I'm sending those packets from branch 1 to branch 2, my sequence was 1, 2, 3, and 4. However, when I received these packets on the branch 2 side, it was out of order. So that is something called the TCP out of order. And these equipments or the vendors, they have some techniques to recover or correct this out of order TCP sequence. So as a receiver, when I still get my first packet first, then second, then third and fourth. This is per flow load balancer. I have a machine which is communicating to my branch, and these are two different applications. So my first application TCP flow looks like this, and my second application TCP flow looks like this. So let's look at the animation here. My first packet reaches to remote branch over the MPLS. My second packet, third packet, fourth packet. So my first flow goes over MPLS, and my second flow, it goes from internet. So this is a feature where I can prioritize what should traverse over MPLS connectivity and what should go over the internet. And same time, I can also do the bandwidth augmentation, so both the links are being used. And my load balancing, it works based on the flow. But this is not simple as it looks like. So let's assume if I go for the legacy networking, my first router is here, my second router is here. I might have multiple links in between. So let's assume I have two. And first link is 10 Mbps. My second link is also 10 Mbps. If I'm running a protocol like BGP, maybe OSPF, it's very straightforward. I can do a term called ECMP. In ECMP, it is going to do my distribution of the flow across all the available links. However, the challenge I see in the legacy world, I have only one protocol available which does unequal cost multipathing, which is going to be the EIGRP. Another challenge I see, let's say I have this 10 Mbps link and 5 Mbps link as a secondary. And now we talk about the per flow. So flow is something which we should have the deep understanding. Maybe my first flow, it goes over the 10 Mbps. A lot of bandwidth is available to accommodate this traffic. My second flow, it goes over the 5 Mbps link. Initially, it might look like a simple flow-based distribution, but maybe this is the FTP traffic, or maybe I'm doing some sort of the download where initially the download speed, it looks very low. So flow size is very low, but with the time it increases. So maybe this 5 Mbps link is not capable enough to handle that flow. So the term can be used. There can be a kind of the elephant flow, and there can be a mice flow as well. So what we can do, I'm not sure when this feature will be implemented. So in the real world, we cannot do or we cannot achieve a exactly ECMP. Reason behind, if this flows increases with the time, I should have some sort of mechanism. If 5 Mbps cannot accommodate, it should move to 10 Mbps automatically. So it added a lot of complexity when it does the load balancing. So the mechanism what we have, there should be some sort of the monitoring which keeps track which link is being heavily utilized. Then you should move a particular traffic to less utilized link. So for doing that, you should have some sort of monitoring inbuilt or maybe some sort of proving which keeps checking what is the utilization on these links. So it is not going to be the exact equal load balancing, but yes, based on different algorithm, based on the monitoring of the utilization and all those things, somehow you can achieve some sort of the load balancing. The third consideration comes as a security. Earlier, we used to have the firewall sitting in every branch, and you have a lot of rules, what you want to allow, what you want to block, what is going to be the antivirus, which keeps scanning all the traffic what you receive. And same time, the functionality which comes from the IPS and IDS. With the SD-WAN solution and a player like Zscaler, you can solve it. You might have a SD-WAN equipment sitting in your branch, and same time over the DIA you can have the GRE or IPsec tunnel which is going to connect to your Zscaler. So Zscaler as an organization, they provide you the secure web gateways and the peering to your clouds, maybe as AWS, Azure, O365 sort of the applications. And the presence, it definitely matters a lot. It is all about the user proximity. So they have around 150 data center in 6 continents, and you're going to get the full visibility on your traffic, full visibility on your SSL. So you know what is going on those tunnels, what are the top talkers as far as application awareness is concerned. So let's take a look how it looks like in the real world. I have a branch 1, I have a branch 2. They both have the same connectivity to two different service providers. So service provider 1, service provider 2, and you have a POP, or maybe I will call it a data center 1, data center 2, which is owned by the Zscaler. So over the internet, you are going to have two tunnels to two different geography location or the nearest POP. So if one tunnel fails, you can still utilize all the services provided by your Zscaler. So all the traffic, it flows over the secured IPsec or GRE tunnel. It reaches to the POP, and Zscaler is going to host all these applications what we used to use earlier in our branches, the firewalling, the application awareness firewall, scanning, traffic scanning, IDS, IPS, and application awareness. So once you reach, your traffic reaches to one of the POP, and from there you are again going to have the internet connectivity, or maybe there have some peering to the cloud infrastructure. So all the traffic after scanning, it goes out from here. So it reduces the dependency on the firewall infrastructure where you had the fragmented security. When we talk about the SD-WAN feature, a couple of terms comes in our mind. So first, SD-WAN, orchestrator, edge, BFT, TCP, WAN optimization, per packet flow, packet duplication, segmentation, UDP, FEC, per flow, JTP, controller, application visibility, high availability, management dashboard, active-active architecture, security, virtualization, IPv6, DTLS, MSP, TLS. So all these things we are going to talk in part 3. Thank you everyone for watching this.